In this lesson, we will cover how we integrate methods into structs. What we actually do is create a function of the struct. In general, functions that belong to classes in programming languages are called methods. Let's start by creating a simple struct and binding it to a variable. In object-oriented programming languages, objects contain data and methods. But we know that Rust uses structs instead of object implementation. When defining structures, we specify the data they should contain. To associate methods, we need to create a separate scope with the keyword empl and write it in. After the struct is connected to the variable, we can call the methods we created with the dot operator. As you may remember, we were able to access the fields of the struct in this way. Another aspect commonly associated with object-oriented programming is the idea of encapsulation. Instead of accessing the fields of the struct directly, we will encapsulate. Because accessing fields directly can cause some problems. Now let's write our first method. Here we will borrow the struct to access the fields of the structure using the keyword reference self. In addition, although we haven't seen the modules yet, we can make the function public with the pub keyword. Since we are working on the same file, there will be no problems at the moment. However, the functions that you will use while working in different files must be made public. Let's assign the value from our function to the variable and print it. Let's say we take a little tour in our car and the amount of charge in the battery is getting low. Let's write a function where we can add some charge. You can use 4 keywords in total. Let's write these. Our keywords are self, reference self, mood self, and reference mood self respectively. Determines whether this function will access the values of the struct either by taking ownership or by reference. As in our other example, we use the keyword mood self instead of ref self. Because in our other example, we just wanted to access the value. We had nothing to do with the changing the value. We took it as mood self because we will change our value. But if we pass the ownership completely to the function and do not return it, the value will be inaccessible when the function is finished. The reason why I do this stems from the thought that it might be more useful to show the difference with an example, because we needed to use reference mood self. Let's run the code and see the difference. The difference of mood self from reference mood self is that it transfers ownership completely to the function, so data security is guaranteed during the process. Subject to if you don't revert the struct to another variable, the struct will be inaccessible once the scope of the function is finished. So let's borrow ownership here as ref mutable instead of mutable. As you can see, it wants us to add the keyword mute to our variable. Let's fix the problem. We accessed the value as mutable and changed it. Moreover, there is no need to return the ownership in the function. Of course, there are also uses where the ownership is mutable. For example, I suggest you review the builder pattern. Moreover, you can also print the variable directly. Our aim here was to prevent possible errors by encapsulating the variable.